Okay, now what remains is D and L, plus and minus. D is known as dextro rotatory, L is known as levo rotatory. Levo rotatory is also represented by negative sign and dextro rotatory is also represented by positive sign. Now what are those? Obviously that has got to do something with rotation. Alright, now let's understand polarimeter. Polarimeter has got sodium or mercury vapor lamp. Now why is it? Because it throws out monochromatic light. Monochromatic light is, in case of visible light, it has 7 colors in it, mixture of 7 colors, right, starting from 400 nm to 750 nm and that ways, right, that range. It has got violet, indigo, blue, green, yellow, orange, red whipped here. All 7 wavelengths mixed together forms a visible light. Whereas when we talk in terms of sodium or mercury vapor lamp, it only throws light of 1 wavelength, so monochromatic. So monochromatic light comes over here. Now monochromatic light, whenever monochromatic light is there, its vibration is in all direction, just like this. It vibrates like this, like this, like this, like this. It vibrates like that. Alright, we call it as unpolarized light. Alright, then it passes through polarizer, and polarizer, when it passes through polarizer, it now vibrates only in one plane, and that plane is that of polarizer. Alright, this I can try to explain you. Now suppose this is a nail to which I have tied a string. This is a nail to which I have tied a string. Alright, and I am just doing like that, like that. I am just moving it like this, like this. So what will happen? This will be like that, 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 like that. So basically it would be vibrating like this, like this, like this, like this, like this, like this. So it would be vibrating like this, like this, like this, like this, right? Alright, now suppose same thing I do. So this is in comparison with unpolarized light. Alright, just an example to make you understand. So tied a thread and I'm doing like this, like this. So it is becoming just like flowers, like it is becoming and going like that. So that's how it is going, like this. So this is what is unpolarized light, which is coming from here. Fine. Okay, now what do I do? Now I again same nail I have tied over here, and to that I have tied that thread. Alright, I have tied that thread and I have put a cardboard there. Alright, I have put a cardboard there, and in that cardboard I have made a slit like this, and the thread is passing through this slit. So what will happen is, and same thing I am doing over here. Here I am holding it and doing like that. So here I will find it going like that, like that, like that, like that. Anyways, but once it comes out through this cardboard, it would be like that. It would be only vibrating in that plane. Alright, so consider this to be polarizer. That is what the polarizer does. It changes the unpolarized light to polarized light. And how does it vibrate? It vibrates in the plane, in the plane of polarizer. Alright, so it is just simple one going like that, and it passes through this. This is the polarimeter tube. Here we place in sample, and this is the place from where we observe. Alright, so what I have done is I have taken simple, just neat solvent and placed it over here. This is the sample space. I have placed the solvent. I have just placed the solvent in which I am going to dissolve my material. I am going to dissolve my material. Say I am going to dissolve this material in chloroform. So I have kept chloroform over here, and when I am observing, light passes from here, unpolarized, it gets polarized. It's like this, plane polarized, and this is what I am observing. When I am observing here, I am finding this plane, this thing, right? Now what I do is I take it out and replace chloroform with, I dissolve this in chloroform, mix it well and place it over here. Alright, when I place it over here, and then when I observe, I find that it has rotated that plane polarized light towards the left direction, LL, left direction. Alright, by say 30 degrees. It has rotated it by 30 degrees, alright, towards left. Fine, noted. Then what I do is I remove this, and now I put in this sample. I again take this, dissolve it in chloroform and put it into the sample space, and I place the sample space here. Then when I observe, what I find is now the plane polarized light is rotated towards the right side. And by how many degrees? Same 30 degrees. Same 30 degrees. Alright, so this was left, so I call it as minus 30. This was right, so I call it as plus 30. Alright, since it was towards left, I call it as levo-rotatory. I call this as levo-rotatory minus and levo-rotatory. This is dextro-rotatory and positive. This was just an example. I am not talking about this specifically. It's not like this. Alright, it doesn't have plus and minus. But just to explain, I just try to put in that both would have opposite optical rotation and the degree of rotation also would be same. So what would happen if I take the mixture 50 of this and put it in this and then check? Obviously we'll find that we would see only this. Why? Because 50% of this would neutralize 50% of that. 50% of negative 30 or levo-rotatory will neutralize the 50% of dextro-rotatory or positive rotatory, and as a result we would end up with no rotation. And that is what I told when 50-50 is there. I told that it would be the racemic mixture if it is 50. But these are what? These are optical isomers. Optical isomers. Alright, optical isomer, or we can call them as enantiomer, as I've noted somewhere, enantiomer. I can call it, this is one enantiomer, the negative enantiomer, positive enantiomer. Negative optical isomer, positive optical isomer. If it is mixed together, it's racemic mixture, no rotation. Alright, so understood this part. So this is what has got to be bore in mind before we talk about chirality. Alright, I tried my level best to make you understand. Alright, so hope it's all clear. Okay.